Good morning, everyone. So I wanted to post this video kind of walking through the manipulations that you can use for this acceleration equation that we've been going over in class. I want to own right up front that these manipulations are not easy. They're not something that was going to come naturally to a lot of us, and that's completely okay. They're a difficult thing to do. So I wanted to create this video as well as offer a chance for you guys to attend office hours today after school for anyone who's still confused about these manipulations and how to complete them. All right, so today we're going to walk through the possible manipulations of this acceleration equation. Now, there turns out that there are four possible manipulations. The first of which is what happens if we are given information about final velocity, initial velocity, and delta t, and asked to solve for acceleration. We are simply going to use this equation here to solve for that by plugging in the final velocity, the initial velocity, and the delta t, and performing the desired operation, whether that be minus or divide. Okay, so once again, these would be your givens. Would be v final, v initial, and delta t, the change in time. All right, where your u, in this case, would be a. Manipulations here would be none, all right, because we already have an equation for acceleration as a is equal to v final minus v initial divided by change in time, delta t. Now, it's always a good idea to put these in parentheses so as to make sure that you all know that you do the bottom first, not the top. You are always going to, when you manipulate, want to bring this denominator, the thing on the bottom of the fraction, over to the left side. So, everyone, this is the manipulation for acceleration, which in this case doesn't really count towards a manipulation, and is more of just when you are given final velocity, initial velocity, and the change in time, simply use the equation for acceleration, plug in your given variables, and solve for acceleration. So now that we've gone through this idea of how to manipulate our equation, or in this case, how not to manipulate our equation for acceleration, let's go through our next big item here, which in this case is going to be, let's say that we are given, so for number 2, excuse me, pardon me there, let's say for number 2, we are given information, all right? Our given information is as follows. We are given the initial, we are given acceleration, and we are given the change in time, all right? We look at our total number of variables that we have here, okay, and it says that I have initial velocity, acceleration, and change in time. That means the only thing that I would need to solve for would be this v final in our equation. So our unknown in this situation, because the only variable left that we do not know any information about, is the final velocity here. So when we manipulate that equation, we are going to manipulate for v final. So our goal here is going to get that it is v final on the lone on the left side is equal to something on the right side that includes the initial, acceleration, and delta t. So our expression should include these variables. All right, they should include these variables. So let's go ahead and walk through this manipulation a little bit. So to start with, all right, here, we go ahead and get this pulled down here. We are going to want to write out our original equation, which would be a is equal to v final minus v initial, all divided by the change in time, or delta t. I'm going to go ahead and draw that line down through the equal sign so we know exactly that we want to get everything to the left side of this line. So when we want to get everything to the left side of this line, the first thing I'm going to want to do here, all right, is I want v final alone on one side. So the first thing I'm going to do, because we look at SADMEP, right, we do addition, subtraction, multiplication, division, and then parentheses, right, and then parentheses. So we're going to start with this division. Now I have a line here. All right, remember, this bar means division. All right, now how do I break division? I'm going to multiply. So to do this, everyone, I'm going to multiply both sides by delta t. And again, that is a measure in order to break this division line here, I need to make sure that I'm multiplying both sides by delta t. Now, whenever I multiply a fraction by the thing on the bottom, so in this case it would be delta t divided by delta t, those delta t's cancel. All right, anytime you divide a number by a number or a variable by the same variable, they cancel out to equal 1. This produces the equation a delta t is equal to v final minus v initial. And now all I need to do is I want v final alone. So what I'm going to do is I'm actually going to add this v initial over the time. So remember, the opposite of subtraction is addition. So I'm going to add v initial to the other side. So add v initial over here. And that's going to lead me to the final equation, which I'll put over here for you all. That final equation, which is that v final is equal to a delta t plus v initial. And this is the expression that we can use to solve, all right? Excuse me. This is the expression that we can use to solve for any final velocity, given that we know information about the acceleration, the change in time, and the initial velocity. All right, so now up to this point, we have three essential equations here, right? We have three essential equations. We have the acceleration equation, all right? And now we have this equation for final velocity, all right? The next one that I want to go over is what happens if we are given. So for number 3 here, all right, for number 3, what happens if we're given information on everything except for the change in time? So for 3 here, our givens are going to be that we know information about the final velocity, g final, the initial velocity, g initial, as well as the acceleration, a. While we do not know information, our unknowns, we do not know anything about the delta t, or the change in time, or the time it took to produce this. So our manipulation step is that we are going to want some expression that such that it is delta t is equal to some expression involving v final, v initial, and acceleration. All right? Now that expression, how we get that expression is what we're going to do when we manipulate. So we write out our equation for a. Once again here, we write out that equation for a, which is equal to v final minus v initial all over delta t. All right, and now we're going to want to solve this for delta t. So again, my goal here, everyone, is to get delta t to the left side of this equation. Now again, this bar means division. So this little fraction bar here means division. And let's not forget that these are in parentheses up here. If the parentheses aren't there, they are implied because any operation on top of a fraction is always done last. It is always in parentheses, okay? So to get delta t, I have a division, so I need to multiply to get delta t to the left side. So I'm going to multiply both sides by delta t. Once again, multiply both sides by delta t. Now, when I multiply this side by delta t, I'm essentially dividing delta t by itself. And anytime you divide something by itself, they cancel out. So these should cancel as they did last time. This leaves you with this equation of a delta t is essentially equal to v final minus v initial. Now, what am I going to do now? Because now I have a delta t on the left side, but it's not alone, right? I want this goal to be that delta t is alone on this side of the equation. So I want this all on its own, so I need to get rid of the acceleration. Now to do that, remember, there's a multiplication implied here. A times delta t. So to get rid of delta a on this side, I'm going to divide by a. And I'm going to divide the other side by a as well. Once again, when I divide a variable or a number by itself, those variables go away, and you are left with just delta t is equal to v final minus v initial divided by acceleration. So if we go ahead and write that out over here, we'll notice that essentially we just swapped the delta t on the left for the acceleration, right? These two variables just swapped. So that leaves us with the final equation for delta t as delta t is equal to v final minus v initial divided by the acceleration given in the problem. Now we're going to use this equation anytime that we are given information on the final velocity, the initial velocity, and the acceleration, and asked to solve for how long it's going to take to get to that point. In a moment here, I'm going to extend this so I have enough room to keep working here because we have one more manipulation we need to go through. One more manipulation that we need to go through here. Now, with that being said, okay, this last manipulation is by far the most complex, all right? So you won't see that much to do with it. You won't see that many problems working with this one. But I want to make sure you are given it just so you have information on it and you know how to work moving forward. So the last manipulation is going to be if we are given information on the acceleration, the final velocity, g final, and the initial time or change in time, delta t. And our question is asking for information about the initial velocity, v initial. What are we going to do there? All right. Our goal, of course, is that we're going to want to manipulate our equation, right? For something like v initial is equal to some expression that involves v final, acceleration, and delta t in some way, shape, or form. So this is our goal right here. So to do that, we are once again going to write out that equation that we've been working on up to this point, which in this case would be that a is equal to change in velocity over change in time, as we've done in the past. So this would be a is equal to v final minus v initial divided by delta t here. And now we are going to want to manipulate this expression right here. Now, notice that once again, I have that delta t on the bottom of that fraction on the right. You'll have noticed that in each and every manipulation that we've done here, I have multiplied by delta t first. And you're going to find that's true in all cases because that's what gets rid of this division sign here and allows you to start the manipulation. So again, the first step here is going to be that I'm going to multiply, all right? I am going to multiply by the delta t. Remember that by multiplying by the delta t on the right, I am essentially allowing us to cancel it out because it's delta t divided by delta t. And anytime you have a number or a variable divided by itself, they just cancel out. So that leaves us with this equation of a, all right, times delta t is equal to v final minus v initial. And now I want to solve for initial velocity. Now, the tricky part here is that, yes, now I have this minus sign in front of the v initial. And I have a couple options, right? I want v initial alone, so you could subtract the v final to that side and then divide everything by -1. But to alleviate some of the difficulty of this problem, it's actually easier to split this into two steps, where first I'm going to add the v initial to the left, and then I'm going to subtract everything else on this side over to here. So let's go through that process first. So the first thing I'm going to want to do, as I mentioned earlier, is I'm going to want to add this v initial to the right side of the equation and add v initial to the left side of the equation. All right, so it's v initial plus a delta t is equal to v final. We know that equation already. We know that negative v initial plus v initial actually go away and this becomes 0. So you're left with this equation that v final is equal to v initial plus a delta t. Now, the last step here, everyone, is to go ahead and get rid of this a delta t on the right side because remember, I want everything. I want v initial alone on this side of the equation. I want v initial alone on one side of that equal sign. So that's what I'm going to do here is I'm going to subtract. Remember, I have addition. So the opposite of addition is subtraction. So I'm going to subtract a delta t from the right and subtract a delta t from the left, and that's going to give me my final equation for v initial, which would be that v initial is equal to v final, the final velocity, minus the acceleration times the change in time. And this will be our final expression for initial velocity in terms of the acceleration, final velocity, and change in time. Everyone, I hope that this was helpful for you all. Please watch this video as much as you can or as much as you need to to get an understanding of this problem. We will go over more of this in class. And again, I will be offering office hours today after school on Monday.